Hello. In a number of recent videos, I explored the moon's orbit around the Earth and the phases, mainly as a response to that guy who ultimately took his channel down. There was one more thing that I wanted to explore on that subject, which was the moon phases and how you would go about calculating it. During the back and forth between that guy and some others, such as Blue Marble Science and Where's Wally, that guy kept confusing the moon's phase and the moon's angle. And it's already covered in some videos. I'm not going to cover it again here. But what I want to do in this case is to explore the relationship between the moon's angle and the moon's phase a little bit more than what I did in this one here where I created a lunar cycle animation. So in this case here, I created an ideal orbit where the moon is always at the same distance from the Earth and the angular velocity remains the same throughout the entire orbit. The phase is the cosine of the angle, and you can see the formula here. The angle percent is simply a percentage from 0 to 180 and then back down to 0 and then back up to 180 every 180 degrees apart, as you see here. I also added another column, which is the difference between these two, and that's represented by this yellow line here. So this would be the ideal perfect circular orbit math. We do know that the moon's orbit is somewhat eccentric and that it will be closer to the Earth and further away from the Earth. And as a result, the angular velocity keeps changing throughout the month. But then what I did was I took 360 degrees and divided by 29.5 days to come up with 12.2 degrees per day. Each row is another day, and the phase is taken from timeanddate.com. So I started on December 25th, which is a new moon, and you can see 0.3% is 0.3%, 2.7, 7.2, and I kept going into January all the way up to the new moon and put those values in here. The angle percent is calculated the same way as it was in this one. And then I also took the difference again. And you can see that it's not quite symmetrical because the moon is eccentric in its orbit. But now the main reason why I wanted to make this video, how would you go about calculating or estimating the percent illumination? So just a little bit of a context. If you're on the Earth and you can see the moon in its different phases, if the sun is to the right and it's shining to the left like this, the right half of the moon will always be illuminated in reference to its position with the sun. But since the moon rotates around the Earth as well, we see a different part of the moon at different times of the month. So if we are seeing the moon dead on like this, it will appear as if it's a full moon. If we see the moon at an angle like this, again with the sun's rays coming from the right, we will see mostly a full moon, and we're going to see part of the moon's face will be in the shadow. Over here where it's closer to a new moon, of course, here most of the moon's face is in the shadow and we only see a small part of it. So you can see that no matter where we're looking, we see pretty much 180 degrees. But what that 180 degrees happens to be determines where the terminator line will be. So in order to calculate the moon's illumination, it's very simple. It really is how much of the moon is lit relative to its overall area. But a very simple way to do that is to measure the width of the moon that is illuminated and divide that by the total width of the moon. So finally, to give a real world application example, on November 4th of 2019 at 8:59 p.m., I was helping Tommy Grønvold with one of his moon experiments. I think what I'll do is I'll go find his video and I'll link that in the description below. And I had taken some pictures of the moon for that experiment. So I'm going to use one of these photos as an example. So I'm just going to load that in GIMP. So here's the image, and I would like to know what percentage the moon was when I took the photo. So the first thing I need to do is measure the overall width of the moon, and I get about 138.4. I'm doing this so that I don't have to try to find where it was over here. So now let's go and measure. Okay, so I kind of eyeball it at 76.7. So let's put those values in a spreadsheet. So there's 138.4 and there's 76.7. And I divide 76.7 by 138.4 and convert that to a percentage. And then I get 55.42%. So this was the time and date that I took the picture, and let's compare that with November 4th, 55.4. So that's basically what I wanted to show in this video. If you liked it, don't forget the YouTube troll. Thank you for watching, and I will see you again in another video soon enough. Bye for now.